geospatial data, you can write to us. So for the research scholar, we're giving this data set free of cost. And I'm also an ISO, which means Information Security Officer of NESAC, which takes care of all the cyber security and all those things. So a lot of things. Yeah, come. So in NESAC, we have been creating a lot of thematic data sets, okay? So which means we are supposed to, give this data to different kind of users so that they can use this for their planning purposes. But if you see 9 years back, ago, whenever this government officials, when they want this kind of data, they used to come to our office and then they want these maps to be printed in A0 sizes, which means and then a lot of security clearances which they had to undergo. So a lot of inconveniences, okay? And then plus these maps are kind of static. You cannot rescale it, you cannot resize it, and then you cannot zoom in. So kind of static maps. But then they were after this one. They had, a lot of time had to be wasted for this. So that is why the GeoWeb comes into picture. So which means you can keep your data in a server, and then you can serve your data as a services. So that any user from any part of the world, remote, they can access this data, and they can use this. And also once you serve this data, the user can access this data from multiple servers. It's not that the data has to be accessible from only from one server, so that they can access this multiple data sets from different server, and then they can use some kind of massive kind of applications which can be used for decision support system by different line departments. So that is why today we'll try to understand what it is, and then most of the beauty part of it is that we will be using open source to create this kind of services and applications. Okay, so this is my email ID. So in case if you want to know more onto this, because in 1 hour it will be difficult to cover entire thing. So you can note down my email ID so that you can always write to me. Okay. 1 second. Yeah. 1 second. Okay. Try to get beyond. Okay now? Visible? You can take note. This is nesac.gov.in. Last one is a .in. Huh? So the first one is we'll try to understand the GeoWeb services and what is open web mapping. But the second and third part, I think it's for the practical, but then I'll give you a walkthrough of this so that, and this entire material you can download from this GitHub. So you can also note down this one. So that these two, you can do it. It's a kind of a DIY. You can do it yourself. Okay, you can just follow this step-by-step process are given. But then if the time permits, I'll again go through this slide and then tell you how to use this. Okay. But anyway, you can download this materials from this URL. It's github.com, that same poem. This is meant for this purpose only. Also, there are some ebook on the WebGIS which you can use it. Okay. So we'll try to understand the GeoWeb services and open web mapping to start with. Lecture will be like this, some background on 10%, and mostly we'll try to understand the concepts of open sources and the data services and some of the web architecture and technologies and platforms. So you'll be learning why we're using space-based data, why WebGIS, and how to download or how to access these data services. And then and then some concepts on open sources, standards especially. And then how you can create this one architecture, especially how you can hook up this different tools to create the applications. And so far for NER, we have been developing these applications, especially the standalone. As you know, in the NER, there's a lot of connectivity with the bandwidth. So even this, the entire application has to work even from the pen drive without having, they need not depend on the internet. So under which we created this ASBIG, the space-based information kiosks, which is a state-wide data we're keeping on a standalone manner, so that anybody with a pen drive, he can just hook to this one laptop or the workstation. The entire applications will be live. Okay. The NEDRP is with regard to the district resource portal, discovers entire districts of NER. And SILKS is for sericulture applications, which we're doing not only for the NER, but also for it covers around 178 districts of India. And then how you can, also we're creating a lot of OGC, data services for India, which anybody can access and use it, and other portals. So, okay, what's that? So why is space-based data for planning? The first one is like we follow a lot of scientifically methodology, this thing. So these are scientifically derived data. Like we follow capturing and processing and validating and ground truthing has been followed meticulously. And also we can update this data on time to time. Like if you talk about land use land cover, like 20, I think 5, 6, 11, 12, and then recently 15, 16. So we have been updating this data. And it's very easy to maintain and manage the data. So this aspect I'm talking about with respect to the web services. And also we're creating a lot of action plans when we combine these multiple data sets by applying a lot of multi-criteria analysis. You can create a lot of action plans both for land and water. And most importantly, the statistics can be very useful for preparing the DPRs and master plan, all those things. And also it can be used for many applications like disaster management and infrastructure planning, okay? So WebGIS is like, the advantage is like, okay, supposing if you want to create one application, okay? So data, but then you require DM, wetlands, village boundary, and auto photos. But then this data reside in different servers, okay? So the beauty of WebGIS is that you can combine this, this data can come as a service, okay? One DM from NESAC, or from wetlands from MARSAC, okay? From MARSAC, you're taking the village boundary. So all this can be combined together in your platform, and then on top of it, you can build all those decision-making tools. So which means you can get the latest data, and then it can be any format, okay? Format is irrelevant, and it can be of any sizes, and then software independent. This one, the browser is the only thing that you need to have, and it can be open, it can be accessible on any kind of devices. And of course, that's why it saves a lot of time. This is regarding downloading and accessing of data as of now. So I'll just quickly tell you how to download the data. You must be knowing about Bowen, yeah? So it's right now, if you go to that, you can download the data satellite sensor-wise, okay? When Cartosat 1, then OceanSat 2, ResourceSat, this one, 1 and 2. And if you go to the theme-wise, you can also download land and terrain, all those things, okay? So the moment you select, I go for this. 1 second. Let me second this one. Supposing this one, you can select this Carto them, the 3 latest one. Then you can select, you can, if you know the bounding box, the bounds of your area of interest, you can define, or you can do interactive drawing. You can just it's just not visible. The Windows having some problem. So what you have to do is you have to draw your area of interest like this, and then the moment you select your tiles, you can just go to the next, and this is the kind of data that you have. So before, you can also view your data by clicking to this. So this is one tile you get, and also you can see the metadata, what the data is all about, regarding all the extensions, okay? So all those metadata and how the data has been created, all those things you can read, and finally you go to the download. So this way you can download this data free of cost. So in case you are able to download data, you can do it. But otherwise, if you need any data which is not here, you can always write to us. So we can give the data for this thing. So okay, and next is also, so this is regarding data, but also like in case you are developing your applications, straight away you can consume these thematic data sets, which are being served through Bowen thematic services. So this is the URL. Okay, so, supposing you want the land use land cover of map of 50K, 5/6 for example, then you have to select your state name. Okay, you can see, first you can visualize your data now. So this is land use land cover with these classes. Okay, and you can also go district wise, like Jorhat. So this is how it looks like. And then if you go to the web services part, so you have to take note of this URL, okay? So idea is that if you have if you have a quantum GIS, you can access this data in your quantum GIS platform, and based on this, you can start digitizing or something. Okay. Else, if you're developing some kind of applications, also you can you can add this layer as a one layer out of your this one. You can consume this data as a separate data into your applications. Okay. So this is the one the URL you're supposed to know, and as well as the name of the layer. So once you know this two, you can add this in your applications. Okay. So likewise, you can there are a lot of data which you can simply access and use it in your application. Okay. Okay. And thirdly, we're also giving, like I said, NER being a lot of having internet connectivity. We're giving this standalone these applications for various line departments. So they're using it. So they need not depend on the internet. So then once you have this kind of data and services, you can start building your applications with regard to resource monitoring and management, and then for assisting in planning activities like this DPRs and master plans, applications for disaster management, and spatial decision support system tools which you can create using this. And then this is one application is accessible on multiple platforms. So you need not design these applications for like mobiles or desktop versions. So one application serves for all the this heterogeneous kind of platforms. Okay, so next is okay. I think this is done. But the point is now, see, like I said, entire applications has been developed using open source. So then, what is open source? One is open standards, which means you can read the standards, and based on that, you can start implementing your applications. Okay, because some standards are closed. Okay. Without knowing that, you cannot just start implementing it. So standard is open, and then also the source is open. Okay, it's open source, which means which helps in bringing your applications interoperability and freedom. Okay, so free as in freedom. It's not free cost. Free as in freedom means you can modify the code, you can make changes to the code, and you can redistribute any number of the software to the users. And as you may be knowing, this is quite popular. If you see the supercomputers, all kind of 90% of them uses open source. 60% of internet servers rely on the open source. Even in the smartphones, 60% of them are built based on this open source. Okay. So like I said, the free as in freedom, and and then we have a lot of collaborations to create and improve and extend this bug-free software. And then here we're talking about thousands of developers. Okay, if you talk about the company, they have only hardly 50 or 200 numbers of developers for developing the software. But here we're talking about a lot of volunteers or community developers, we try to create and even extend these applications so that it becomes bug-free. And also they also focus on the portability so that it can be used, kind of plug-and-play kind of applications. Okay, which is very. Otherwise, other applications has to be properly installed, and then you have to restart your machine. Then only the applications can be useful. But in this case, you just have to plug in the application so that without installing the applications in your OS, it becomes useful. And because of which, it is very excellent tools for research and development. Right?
So is it platform independent?
Yeah, all are. So coming to OpenGIS standards, there's a company, kind of group of companies, the 525 plus as of now. So they designed the specifications. So they call it OGC, okay? Open Geospatial Consortium, okay? So they develop encoding specifications which enable the interoperability among diverse geospatial data stores, services, and applications, okay? And in this way, the beauty is that it reduces the need to duplicate data. As of now, like a lot of line departments, they keep on creating these GIS data sets. But again, the same thing, in a form of projects, you're creating those data sets, which are being existing in some part of this thing. Okay, so with this, data becomes, it becomes accessible. Okay, and then there's no any kind of software dependencies. So any applications, any software can access your data as a service. So some of the specifications are like web mapping service. We call it WMS. Okay. So when you create your applications, and then when you see, okay, the application is only good for visualization, and when you don't want applications to be changed by the user, so that way you can serve your map as an image, okay, which means he cannot do anything. Okay, and in case of large map, like you have to do some kind of tiling, so which can be done using WMTS, which we call it Web Map Tiling Service. So that entire map space, like if you talk about Assam, is a big area. If you serve the land use land cover of having around, I think, 270 MB in one go, I think your browser will crash. So your map has to be served in tile by tile. Okay. And in case if you want your data to be served as a feature data set and not as an image, so in that case, you'll be serving your map as a web feature service. So with the transit capability, he can even modify or make changes to the data, okay? Because there are some kind of like settlement locations with the naming, which you are serving it, but then you are confused about the actual name and location, precise locations, okay? So in that case, you can serve that data to the authorized user so that he can adjust those naming, or he can even move the location of those settlements. So which means he can change the data by him or her, okay? And in case of raster kind of data, you have to serve using web coverage service, which we call it WCS, okay? One is then GML talks about the encoding, okay, and the feature informations, okay, which are being used by the KML for presenting the data. Like even in case of Google Earth, KML is being used, okay? So if you're creating a lot of data in the form of KML, you can overlay onto the Google Earth. So these are some of the specifications. This one, which is output of OGC, these companies. So if you follow your these standards, any user, irrespective of his platform, will be able to access your data. So talking about interoperability and non-interoperability, like in this case, this kind of setup for if there are a lot of server, but then if there are a lot of what do you call the interfaces which the client will be using to access this data. And then to access this, you need to understand this interface so that you can access the data from the server, okay? So which means you have to learn these interfaces which are dependent on the server, okay? So which means it's kind of wasted resources, and also like the maps coming out from other different server, it become inaccessible, okay? So in opposite to that, if you have an interoperable system, so any kind of interface should be able to access the data coming from different kind of server. Okay, so using this kind of standards, there's another group called it OSGeo. So they use these specifications and create a lot of projects, okay? And then, so one is like OpenStreetMap. You might have used, anybody use this? So if you go to that, and then this database is like volunteer, so we call it VGIS, Volunteer Geographic Information System. So they keep on creating this data, okay? In terms of, if you talk about vector, it's nothing but line, points, and polygon. So like this is the data which is of Shillong. But if you go to like a city like Delhi and then other cities, it's very accurate and very concise and very dense data you'll get it. So all this kind of data you can export it. Okay, the points, the lines, and polygon, entire thing you can export it, and then so it will come as an OSM format. But then you can again export those layers separately in a SAFE file, and with little bit of accuracy checking here and there, you can use it directly. Okay, and these data are being updated. So that's the beauty of it. It's not that this data is a constant. If you see after 1 week or so, you'll have some changes. Okay, so. So simply what you have to do is you can also do the sign up if you want to contribute, okay? And then for downloading, the moment you zoom into some location, you can simply say export. So it'll give you, and this is your bounding access, the visual access that you are seeing as of now. And then if you go to export, it gives you an OSM data of around, as of now, 5.9, taking all these features all together. So in QGIS, you can import this data, and then you can split out all these points, line, and polygon, and then save it as a SAFE file, which is very usable. So if you go to Guwahati city, again have check, it's a very nice data set, which you can directly use it. Okay, so that you need not again start creating this base map. No. Okay. And then they also do a lot of conferences, like they call it Force 4G. Okay, 2019, 2018, like that. So if you're doing some kind of applications based on this kind of open source, you can also participate in this. So a lot of these are outcome of this OSGeo foundation. One is map server, GeoServer, which are being used very heavily for serving your data. See, before developing your application, you have to serve your data, okay? So that it becomes accessible. Then your application will consume those data as a WMS or WFS and build the tools to interact with the data. So these two are very popular server in open source community. And open layers is for designing your applications, client-side applications, okay? And the geo network is for, make your data discoverable or searchable by the user. Like in a Google, if you type a keyword, it brings a lot of URLs. When the user clicks into that, he can access to the resources. So the idea is that first the user should be allowed to discover the data which he is looking for. So that is being taken care by this geo network, okay? And GDAL or GR are libraries for handling this raster and vector data sets, for building a lot of kind of analytic tools on top of this your applications. And PostGIS is basically for storing and management of your data. So PostGIS has to be installed on top of Postgres. You might have heard of MySQL, okay? So MySQL SS doesn't support this GIS dataset, so you have to use Postgres. But again, Postgres cannot handle your GIS datasets. So that is why PostGIS has to be installed on top of Postgres, so that your Postgres with PostGIS will be able to understand and then store your GIS datasets, okay? And Quantum GIS and GraphGIS are very heavily used open source desktop-based GIS software, which are equally good with ArcGIS or all those things. Even if you talk about ArcGIS, only 20% of the tools are being used, okay? So that 20-30% is already there. And also a lot of, it's basically dependent on a lot of plugins, okay? So if you combine QGIS, nowadays if you download QGIS, it comes pre-installed with Grass. So Grass is very powerful for doing all your image processing stuff, okay? Or you can use GraphGIS as a separate software, but then if you can combine these two, it becomes more powerful. So we'll try to understand what is WMS. So as I said, if you want your kind of applications to be only for visualization, and you don't want your data to be changed by the other users, you can serve your data as a pictures. Okay, pictures mean it becomes an image. He cannot do anything. Okay, he can simply see your data, your map. Okay, and it's very popular and then very easy to implement. So, but then the URL looks like this. Okay, so this is the URL that has to be added like in your application, like open layers. But the actual URL looks like this. So this is actually the WMS server, and you are issuing one request like get map, and this you have to give a name of the layers, like I say NESAC : district boundary I want, and you have to give the bounding box. Okay, the bounding box means the extent of the map. Okay, the first one is the min x, then this is a min y, this is max x, and this is the max y. It gives it's the bounds of the map where the map will be projected. And also you can define the width and height of your map, okay? So based on your application window, you can give the precise the width and height. And EPSG means the projection information, okay? It's a European Petroleum Survey Group. It's a 4326 means geographic lat long, okay? If you know the projection, there's a like geographic lat long, WZ84, a lot of things are there. Instead of telling all that thing into your applications, by simply typing 4326, your applications will understand, okay, this means I have to project into the WZ84 geographic lat long. So your system will understand. So it's a kind of codification of that entire projection, okay? And format as a JPG. Finally, like I said, it will return as an image in the pictures. So what format do you want? Is it PNG or JPG and all those things? You can specify. So PNG is good for it is good. This means if you overlay these multiple maps together, your maps will be transparent. Okay, all the extra white spaces will be removed. Okay, if you give in the PNG. So this is how the WMS URL actually looks like. So if you give this onto that browser, this is what you will get. This kind of picture you'll get. Okay, and this is a simple this one. What's that? Image. And then this is how the request flow works. You issue this HTTP request. It goes to the web server. Then It will again give a get map request, which will be sent to the Geo server. Data will be here, and then it gives you the written request as an image, and gives to the browser for displaying. But then one WMS request, you can give multiple maps. It's not that for every maps you have to create these multiple URLs. In one single URL, you can specify 3-4 maps, so that it gathers all the maps together and will be overlaid on your platform. Okay. And like I said, WMS cannot give data away. Okay, it just simply an image that it returns. Okay, so he cannot do anything. But then he can do some querying. Like if you click onto the map, like if it is elevation or DM, it gives you the elevation information. If it is district boundary, it gives you maybe the area of that district and some information. So those things can be retrieved, done by the user. So then WFS, like I said, if you want the user, if you want him to make changes to the data, you can serve your data as a WFS, where he can do the insertion operation, update, he can delete the map, he can also do the querying. So all these things he can do it. And okay, and again with WFS, with a single WFS, okay, this is regarding that. Okay. This is regarding, you can also issue the get feature request, where it gives the feature and attribute data as well as it gives it, 2 things. One is the attribute data, second is the feature itself. And similarly, with one WFS request, it can give multiple data. Okay. And for coverage, you have to use WCS if you are serving some kind of the DEM or this thing. Okay, raster imagery, you have to use WCS service. And OGC allows you to combine this multiple the services. One maybe from WMS, other may be coming from WFS or WCS. So entire data you can combine it together, and then you can create your HDSS applications. And not only this thing, it can the OGC has a lot of standards. If you go to the OGC, it can collect data from multiple sources. It may be from the airborne devices or different servers. Okay, so if you check it out to the OGC, this thing, it has around 40 plus standards. Okay, yeah, okay, go to that. There are a lot of standards out there. CTGML, if you want to design some kind of 3D modeling, 3D model, if you want to display on your browser, you can use CTGML. So there are a lot of standards out there. Okay. But commonly these are being used, this web feature service, web coverage, web map service to start with. Okay, so one thing is, okay, like I said, for the Geo network, where you want the user to, start searching and discovering the data. So we should be the first step. Before accessing, he should be able to allow to search. Okay, like land use, land cover, or some kind of data. He should be simply able to type in a keyword, and then the moment he gives the URL, on one click he should be able to access. Okay, so he can give like query like where, when, based on temporal, how, what is that, and who, based on the owner of the data. So all this kind of the querying he should be able to do into the platform, and based on that he should be able to get those URL. It may be WMS or WFS or WCS. So this is being taken care by this one, the data cataloging thing. And also, like in many of the complex applications, user is supposed to do some kind of processing function on the web. Okay, like you normally do to the DEX of GIS. So same thing you can do it with there's one more service called WPS, Web Processing Service. If he wants to perform some kind of like buffering from this river site, I want to, therefore, like if something like a flood occurs, so alongside of this river, like 10 meter or 20 meter, I want to see those affected settlements. So with some kind of buffering technique, okay, he can collect all those settlements locations, okay. So all those things, processing functions, he should be able to do it. So that you can do it. He can do it with WPS. So one more service is there. So with this, okay, I'll go to the application part. Some of the architecture. So WebGIS, like I said, is it should have a basic GIS functions with internet technology, and it should be accessible through web, and it should have a less complex interface. Okay, but then as I said, depending upon the user's requirement, we give these tools. Okay, even using processing function as well. So that depends upon the user. And if you talk about the features of WebGIS, it should have a wide accessibility. Users from the world can access your GIS data without any GIS know-how, and they can perform this GIS analysis on the web. Okay, and then okay, so they can also incorporate up-to-date real-time informations. And then there are many open-source software which one can use this to create this WebGIS, like MapServer and GeoServer is for serving us the GIS data. Degree is there's also one more software like similar to Quantum GIS. Degree can be used for analyzing your maps, and also it can be used for creating a lot of style maps, which can be used later on by the GeoServer for publishing. And then again, this is how the WebGIS works. Most importantly, you need to have this GIS server which takes care of rendering your GIS maps to the web server, which are being finally displayed onto your browser. So these two are very, very critical component. And you have two modes of developing web map applications. One may be thin client, which is server-side dependent, server-side applications, where all your processing function, all your web tools will reside on your server. And one is thick client, which is client-side applications, which means some kind of like, you might have heard of Java applet. Anyone heard of this Java applet? So it needs only one request. Okay, the moment the jar file applet comes on your browser, it need not interact with the server again and again. Okay, for those kind of applications which doesn't require much interaction with the server, you can use this thick client approach. Okay, this is an example again, thin client and thick client. This is a very generic architecture for building WebGIS applications. Okay, on the database side, you have, like I said, Postgres and PostGIS for managing your data, and GeoServer for publishing your data in a WMS, WFS, or GeoRSS or KML. And then in between, you can also use UDIG and then QGIS to test your data. This coming out from your GeoServer, and finally you can start building this application using open layers. Okay. And now there's again for mobile-based kind of applications. There's one more tool called Leaflet, which is very lightweight. Okay. So now every user is having smartphone. So so that Leaflet is a very lightweight applications. Okay. So compared to open layers, so that can be used. Okay. So again, these are the main components. One is your database, and then for storing and managing your data. And secondly, you need to have a GIS server like MapServer and a GeoServer for publishing and serving your data. And then you can also put together this geo network so that your data becomes discoverable. And then finally, you can start building your client-side applications using this open layers, Leaflet, GeoEXT, Cesium. So Cesium is good for building 3D kind of applications. Okay. Right. And then, like I said, this is for database server for managing your data. So it takes care of a lot of indexing, like GIST. This is generalized indexing search tree and R tree, so that when the user queries or access your data, it becomes much more faster. Okay. And like I said, it can store special objects. So this is where if you taken care by PostGIS. So this alone cannot handle your GIS data sets. So once this comes into picture, you can manage your data. For GIS server, like I said, MapServer is a very good one to start with. and it can support for display and querying of hundreds of raster and vector data sets, and it can also do on-the-fly projections. Your source data may be having a different kind of projection, but then you can reproject it on the fly, okay? So that all your maps will sit together, okay? Your multiple maps can have different projections, but the ones you define, okay, 4326, the data can come from different projections, but then all will be reprojected to the 4326 so that it can sit overlay perfectly. And it also has a map script APIs like Perl and Python, which means you can extend this map server for building this powerful web applications. And for GeoServer, it is good for publishing your map into this kind of services. Okay, and it can also do a lot of styling. See, when we talk about the map, if it doesn't have any styles, when you say land use land cover, different colors means different things. So all those styling and all those things can be very nicely done by this GeoServer. And this is good for searching and discovery kind of applications. Okay, GeoNetwork, where you can provides an interface where user can search and discover your data. Okay. Then okay, these are some of the client applications tools. One is OpenLayers 2, 3 is a very old one. Now even 5 is there. Okay. And if you want to use a kind of half-cook, okay, framework based on OpenLayers, you can straightaway use GeoEXT, okay, which means at least 30% framework is already being built, okay. So, which means your development time becomes half of it, okay. If you rely entirely on OpenLayers, you have to do a lot of things, okay. But then if you use GeoEXT, you can start with the framework and you can start pulling all your layers and build the tools. Okay. Then you can also see this GeoMoose, CartoWeb, LayFlat, and this Mango Map, the GeoCommons. All these tools are good for building these applications. All are okay, no? Not feeling sleepy? Okay, so these are some of the applications which you can try if you want to build some kind of 3D web GIS. You can use OpenLayers 3, 4, 5. It has a WebGL and a 3D kind of rendering. It's based on Geospatial 3 plus C++ Terran engine, and it's but it has to be HTML5. Your browser has to be HTML5 compliant with CSS3 and WebGL, so that you can start. Even this is of Meghalaya, so you can see the terrain and all those things. So perfectly, you can display the kind of 3D models or terrain models onto the browser. And this is again using CGM. This is how perfectly you can see, just like Google Earth. So, and then this is some kind of dam in Meghalaya. And even with Google Earth, you can also, take the interface, which means the 3D part you can reuse it, and on top of it you can start overlaying your own layers coming from different these services. Okay, that too can be done in 4 steps. You have to load your Google Earth APIs and create these API functions. Then you can design your layout, and you can start adding this KML. It has to be KML, okay? And this is how on the 3D you can, the layer coming as a land use land cover layer coming as in KML, and if you overlay on top of this 3D kind of thing, so it makes more sense. So in a 2D, if you see 2D in 3D, with 3D, you can visually you can interpret a lot of things.
Excuse me, sir. What are the codes you have used? CSS or any other cascading style sheet you have used?
See, these all JavaScript kind of a base application. No, CSS3 has to be there.
Yes.
Okay, yeah. And if you have a 3D kind of models, you can also overlay like this. Okay. I'll quickly go to some of the applications. Okay. So the idea is that we want to make this, this database available in a single window platform, which can be used for resource monitoring and management in a standalone and offline system as well as online. And then based on this information, we are trying to generate a lot of need-based, location-specific inputs for land and water resources, which basically means action plans. Okay, and then we are doing a lot of customizations, which is based on need and demand base. Okay. So as you said, okay, if you see compare the Wi-Fi hotspot, if you compare with the Northeast and the rest of the area, you can see a lot of this thing problem with the internet connectivity. So that is why the internet standalone and portable applications makes more sense. Okay. And this way we have come up with a lot of applications. One is NEDRP. Okay. By the way, this is the URL. You can note down. So when you go back home, you can see any kind of maps for your district. You can go to this portal. It's a nedrp.gov.in. So idea is that, see, we are serving this district-wise maps. You can go to this. The first one is you can go to this box. We call it Geo Explorer. And then once we have this kind of information, we are trying to create this e-governance applications. Right? One is election e-atlas, which are being used very heavily in the recent Lok Sabha elections by all the chief electoral officers of the this one states. And then for project monitoring of NEC projects, funded projects. And then we're using not only the maps, but also the data coming from the drones and then mobile phones. And then we are monitoring the progress of these projects location-wise. What was the picture? And then if you see after 6 months, how's the change happening? So we are monitoring all those things. Okay, so this way we are able to create a lot of these applications using this. Okay, so this one, you can go to your state, supposing Assam, and I say Kamrup Metro. You can go to this. So it gives you an interface like this. Okay. So by default, it is showing the wetlands and your national highways and state highways. But the moment you zoom in, you'll be able to see other detail as well, other road network, like this may be, I think, some kind of village road or something. Then these are the kind of layers you have on the right panel. So if you're interested in the land resource, you can just click, it will collapse and then collapse. Then supposing land use land cover, just click onto this, you'll see this, okay? And just again click onto the layer, you'll see the legend of this, okay? So this yellow means all the agricultural lands, the built up, the forest cover, all those things you can see. And also you can, now you can start using these buttons, okay? One is identify, means if you wish to identify any part of on this map, click onto that, it tells you what is that. Keep on clicking, it tells you those informations on the map. Okay. And then, okay, so with this you can also overlay with other informations from, I think, what is that? Settlements, locations, okay? So that you know the location of these villages overlaid on top of land use. Okay. And even also you can start measuring, if you know some land parcel around this, you can start measuring the area of it. It gives you the area. Okay. And if you have a Google Earth installed, supposing right now we are not giving any satellite based map, but then if you have a Google Earth pre-installed, by clicking onto this and click on one area like this, it gives a KML file. Okay, so that if you have a Google Earth installed, it can directly fly to that location. And this, supposing if you want to extract this settlements information, you can go to this graphical query. You want to extract this settlement location, you can select your area of interest, double click. See, this is what we have extracted, and you can download it as a CSV file or PDF. Okay. So this way you can do it. And then what is that? Sorry. Then you can also adjust your map scale by like this, or from here also you can give the specific scale. So and then you can also do the searching of the settlements by the name. Okay. So it should be recent. Yeah, here it is coming. So like a lot of things. And then again, if you finally, if you want to download this, see, downloading one is just is GeoTIFF. If you want to download the map as a georeference map, you can select. You can click onto this. that when you load this image, it becomes a georeference. You can load in QGIS, it will load as a normal georeference raster, okay? And then you can select your DPIs, so 300 means it will give you a bigger map. Or simply if you want to print a PDF map in the A3 size, in the landscape mode, if you want to listen on the right, so it gives you the printed map in PDF, which you can again print it later on. Okay? Yeah, like this. So these are okay. So you can go to this. So any maps for quickly, if you want to use it in your applications or this thing, you can use it. Otherwise, if you want the GIS map, you can write to us. Okay. Okay. So this the silks we have done. This is for Ministry of Textiles. Entire portal has been developed using open source. Okay, and as big is for the 8 states of Northeast. Then even we got a national award, e-governance award in 2014-18 with this. One for the silks and one for NEDRP. We got it. So these are the kind of data we have. Okay, all the data based on these categories: administrative, infrastructure, land resource, water, and all those things. And these are the features which you can use to interact with the map. And this is, I just show you how it looks like. Okay. And this is regarding as big space-based information kiosk looks like. So we're giving it entire standalone applications for the states, along with this touchscreen system, initially to the Chief Secretary's office, but then as per the different line departments' request, provided they have a system in their place, we're giving the entire software with the data free of cost, so that they can use this one. So the one important tool is the area profiling tool, which they can use it. So they can draw district or AOI on the map, and based on that, the statistics can be generated on the fly, standalone. Okay. So this is how the area profile looks like. The moment you select the AOI of that, it gives the statistics of that AOI. Okay. So like that, this is regarding that silks. And some kind of like applications like shortest route finder also can be done with open source. And this is what we did as an experiment. Even this paper got published in 2015 on Springer. Very simple one, the alternate route finding based on the different kind of obstructions, maybe point, line, and polygon. And you tell me the alternate part when this happens. A simple experiment, but then it got published way back in 2015. And like I said, the WPS processing function can be used for, see, the moment the user draws a line like this, he's able to get the DM elevation profile of this area. So this is done through WPS, processing WPS service, okay? So if you have a DM, and then if the user wants the profiling like this on the web, he can simply draw like this, so it gives you. And the moment you scroll onto this, it can give you the interactively the elevation. So okay, this is the like a map to this profile. The interactivity is there. Likewise, the even applications can be used, like a mobile applications, to collect the this thing. This is here like a data collection tool for important tourist point. The user simply can put a place mark and give the location of this, and then it can be recorded onto the server. So this way also the data can be collected. Okay, so that was for the first part. Should I go for the second and third? A walkthrough quickly? Fine? Okay. Okay, so one is this, okay, one is okay. I gave you the GitHub, this one, no? Link, no? What is that? So let me open this. Net is okay or not? Internet. Okay, it's trying to open. See, this one you can try by yourself. Okay, this is using web mapping using open layers. Assuming you have the already published layers. Okay, here we're not. Okay, that thing will come in the second one, in the second walkthrough. But here, like provided you have those WMS services, how you can use those layer and consume it in your applications. Okay, so open layers is a one of the mostly widely used tools for creating this. So simply you can follow this, and also I've written what are these, all those things. You can follow one by one. Anything, if you have any doubt, you can write me. Okay, my email ID is there. Okay, and most importantly, three things are required. One is base map and thematic layers, and the interactive elements to interact with this map. So how to add the base map, which layers should be treated as a base map, and what should be the thematic maps, and finally you have to add these tools. Okay, so I've given all the things in a very systematic way. You can just follow this walk through, and then anything you can let me know. Even this entire script is there. Okay, if you talk about this thing, simply you can copy this into your notepad, save it as a HTML. Then you should be able to add this in this case in this slide. And next one is, and then here I'm trying to explain what each line is doing. Okay. Okay. So this is how to add OSM in open layers. One second. This is how to add control into your map. Okay. How to create an overview map. How to create a scale line. How to add the editing toolbar. So. And then the codes are very, very minimal. If you say map add control, new open layers of control, editing toolbar, name of the layer, your tool.
These elements are free in Google, I hope so.
Huh?
Elements are free in Google to download, or elements, source codes? HTML.
This is open source code. This entire source code, you can use it.
It's available in Google.
It's created by me, you know. You can, so this one, net is not working, I think. This problem. See, you go to the URL, you can download this entire stuff.
About the HTML elements.
He has designed those
Have designed it. Okay.
asking you
Have designed it.
download from his site, that site.
Okay. Okay, acha, ठीक है. And this is how to add overlay layer. See, here I have added the Bowen. One is land use land cover of Assam, and then Bowen maps. The Bowen satellite images you can use as a base map. Okay. See, so that is why E's base map is true, and these are the overlay maps. Okay. So you can follow this one, and then let me know. I think. Okay. And next is this is regarding the this one. The GIS server part, which again is a walkthrough. You can go through this. How to install the GeoServer. So I've given slide by slide. You can just follow this one again. So anything you can let me know. How to set up the GeoServer, and then what are this this tool means. So all things has been given nicely, and how to start publishing your data using GeoServer. Okay. First, we have to create a store, then you have to create a layer, and you can start publish. And how you can, after publishing, how it looks like, you can see to this. And again, on WMS, again, I'm again giving you some again. What are each this parameter is doing that, okay? And then this even you can do some querying like using CQL and ECQL onto the GeoServer. You can even do the query part. And again, this is with regard to the map server, which is again equally powerful with like a GeoServer, but the approach is a little bit different. Okay. Here you have to make kind of a map file, one single map file, which takes care of entire the symbology and then adding and all those things. You can do it in one single file, which is called map file. Okay. And then this is for creating styles and all those things. You can add even a symbol like this onto your layer. So all those things you can do it. Okay. This is the basic comparison. Like in case if you want to use WFST, which means WFST with a transit capability, which means if you are authorizing your data to be modifiable by the user. Okay, if you want such kind of applications, you have to go for GeoServer, because as of now this does not support. So there are some trade-off between these two. Okay, fine. So you can go through this to walk through, and then anything you can let me know. Okay, I think net is not working. Otherwise, that is there. Okay, you can see to that. Any questions? Okay, no? Thank you. I think I have taken 1 hour.
So thank you.
Yeah, thank you, sir.
In a very short period of time indeed, yes, firstly, so many applications from where you will be collecting data and integrating data and publishing data. That sort of thing, the kind of platforms they use and the kind of course to be applied to access and arrange and rearrange the data for your publication. You as a publisher, you can also serve people's community with these data available from different sources, integrating your choice of applications in which you are interested, in which you are working. So that kind of thing one can do now using mobile platforms and its different applications. Thank you very much. Within a short period of time, you have given a wide range of things to think and prepare your mindset to orient and reorient in which you are comfortable.
Like I said, anything you can write to me.
Maybe
Yes, yes. This too, as a PDF,
Yeah.
accordingly. Which you
Everything's clear, no? Some questions make sense. All you have from Assam.
no, no, no. People from Bangalore, Nagaland. Right. Yes, yes. They are from Bangalore, not Bangalore.
One from Jammu.
And Jammu. Jammu is also there.
How come you are far away from? But there, like in our NESAC also, like, you know, there is a scientist there, some of the DMK,
Ah.
some are from Thiruvananthapuram, all the, you know,
That is needed also. That is needed also. Kind of action.
we are the capacity building for that they are coming with the UAV demonstration. UAV reception, it's online now, 2 weeks course. UAV is a processing for researching on local processes. Compared with the supply whole supply. Instead of last.
any prerequisites for this? Any prerequisites for this course?
It's open to them. It's after 6,000 rupees to pay. So we have a percentage fees from here.
Within 6,000.
No, no, that will be extra.
That will be action.
That may be, I think, 100 rupees putting very, very nominal.
Ah.
It's not that, you know, but then the facility is better. Like we can compare with the other, like, staff. Those are very good, you know. Basically, I'm very much the open source part. It's in the same processing and it's open source. You get all the source, even the process part is open source, which will be held in November 1st. For that, the journal you can almost have a Twitter next month. If you're interested in that, you can 2 weeks work. Later you can move to my course. If you have computer programming and everything. But entire thing is done by open source, free. That's what as a student Big 40 is kind of a close book. It is very awful. But you don't know what is going inside. Yes. किसी को एक quality report पाए, अंदर में क्या हो रहा है, with open source you can dig into all the things and change algorithms and tweak all those things.
So a lot of tips and as well as details he has provided to you within a very short period of time using open source software system as well as database. So now it is our time to expand on that and accordingly build your application. Build it to your research and analysis area also.
That's what upcoming seminar as well. Education is best use of technology for
November.
It is the separate site. दूसरा भी बेटा तो देते हैं कोर्स प्लस बहुत काम करेगा इस पॉट कोर्स ऑडिटोरियम पे देने के लिए ओके सब लोग पहली बार आए यस 9 to 5:30 शिलोंग में होता है साफ सफाई यहाँ पे बागी नहीं हुआ भाई 9 to 5:30 आपको कहाँ जाएंगे NESAC is a kind of baby center to compare with other research centers. Hardly 36 scientists. And then a lot of things. Biggest center is VCC, Return Service Center. So build the market, research, and then pocket. There's around 4,000 staff. 2,000 scientists plus. हमारा छोटा सा है, but then so German when you come with English to see the kind of works we are doing. 36 is making a lot of things like that. Especially आपको like the projects, method projects can do it here as well. आपको masters का like at least it has to be 5 months or 5.6 months. Maybe I can बता रहा हूँ 2 महीने में आप सिखाएंगे 6 months where time मिलता है
You are having feedback now. Range of application. Where we are? Where we are? We are only in georeferencing, map projection, use land cover, change detection, accuracy. So, but it says no, it's not partly. That's what I like. But it is easy for them because they have computer-based background. Your background is not computer-based. That is why that much sort of applications you cannot develop web-based applications. But one can target. Because you already say more or less path I can do that going to more going to how about I going to all over experience. এগুলো কার নয় রিজন আর এগুলো কাম হেভি করে নয় আমি কি করব ম্যাপ এখন লেভেলে 2 ঘন্টা বলে তাতে এবার ফিরলে এবার বন্ধ করলে আর কিছু বাকি করব হয়ে বাস সেইখানে হ্যাঁ আই না হ্যাঁ এর আপনি এর চিন্তা করো এজন মানে এটা দুজন টিচার হি ফুললি পেইড সাধারণ এটা ম্যাপটো ল'ৰা ছোৱালী জিঅ'গ্ৰাফি কিবা লাগে ম্যাপটো বোলে কোঅৰ্ডিনেটছ শিকাব লাগে পইণ্ট লাইন পলিগন মেপিং কৰাব লাগে সেইখিনিৰ কাৰণে একেবাৰে ফ্ৰী বস্তুটো জানি নলওঁ ছফ্টৱেৰটো জানি নল'লে মই আছোঁ নাজানো নহয় মোক নিদিবা ক্লাছটো প্ৰেক্টিকেল সোমালেতো আৰু এতিয়া আপুনিও সুধিব অন্য বিষ্টাও সুধিব খচি গ'ল নহয় তেতিয়া কেনেকৈ সোনকালে 1 বজাত যাব ডিপাৰ্টমেণ্টৰ পৰা 1:30 বা 2টা মানত প্ৰায়বিলাক পাব্লিক কলেজতো এইটো হয়তো প্ৰাইভেটতো এতিয়া আমালোকে জানে আমাৰতো এখন কলেজত একো হয় নাই कैसे आ सर ठीक है तो आज आपके अभी है जी सर सीखो हाँ so nice we have lost three classes here so we are late by 1 hour because so many locations here participate and then
secondary tech
and the wide range of things have covered within a short period of time.
So even for me also, I'll try to.
Yes.
In fact, my classes basically I have to go for the basic technologies, that takes also time.
Lot of time.
So I'll try to contain it within an hour.
Yes,
After
yes.
that, I will demonstrate on using slides.
Yes.
So try to give our best, and then
For the basic foundation, the idea on which it works, you try to give it even half an hour. Okay, no problem. And then how to get the data and all those, how to this sort of things. They will be more
And since
because all these sciences, what is involved there, other people are ready to provide you check it. Somebody is important, somebody is geography, all these background people are here. And most of them are researchers. And more, half of them are nearly those who have completed their there and searching for jobs. That sort of people are there and working as guest lecturers or contractual teachers. In that way, they are engaged and looking for their enhancement of skills and doing something in the lab. So then they can showcase their work with the students. And in senior level, people are not मूड नहीं है मूड नहीं है यहाँ जो है उनमें थोड़ा जोश है
हाँ सर like last time we went for we have a we have one structured training program for 5 days वहाँ पे गया था सर actually and now sitting on the other end no after so many years very difficult exhaust होता है सर
इसलिए नया जो जनरेशन है हाँ चलिए हाँ इन लोगों को अभी
স্কুলে লেগে যেন বলেছি এটা আশা কৰিছো কি হল ইয়াতে ইয়াতে রানা সানে কি জলটা জুলি কিন্তু আরো তো আহিব কোনবাই থৈ গৈছে গম পোৱা নাই চাগে তাত হ'ব ভালেই হৈছে জিমহে
the organization.